I'm not sure. I'm afraid we need to use math.
There are actually 3 ways for proving triangles congruent, and you may have actually seen some of these ways in your algebra course. The first of which is called the side-side-side postulate. If I know that 3 sides of one triangle are congruent to 3 sides of another triangle, then I can conclude that they are congruent. Visually, that looks a lot like this. If I know that these sides are congruent, these sides are congruent, and these sides, the third side, are congruent, so I have 3 sets of congruent sides. So the statement that would justify would be that triangle ABC, my first triangle, would be congruent to triangle DEF, my second triangle. And in fact, that's what each of these postulates is going to justify. So the other postulate, which justifies the same conclusion, but it's given different information. So the information given in the side-side-side postulate was 3 sides, and in the side-angle-side postulate is going to be 2 sides, congruent to 2 sides, and the angle included between those 2 sides is congruent to the other angle. Okay, so it's still 3 pieces of information. In my first one, it was 3 sides. In my second one, it's 2 sides and their included angle. The third postulate is the angle-side-angle postulate, again justifying the same conclusion. But in this case, my given information are 2 angles, say angle A congruent to D, and B congruent to E, and the side included between those 2 angles. So the side included between those 2 angles would be AB on this triangle and DE on this triangle. So I have an angle-side angle. Now it's very important to note that it's the angle included between 2 sides, and it's the side included between the 2 angles. I can't just have any 2 angles in any side. It has to be this specific circumstance, and we're going to look at some examples of them in a minute. There is one way that you cannot use to prove triangles congruent, which is easily confused, and that's angle-side-side. You cannot have an angle-side-side situation. That does not justify triangles being congruent. You could also see it as side-side angle. It's sometimes referred to as the no donkey theorem because an ass is another name for a donkey. So that is not a method for proving triangles congruent. Before we start looking at some examples of how to use these postulates, let's first look at exactly how we would label congruence between triangles. So first off, I can't just label any 3 vertices in my triangle with any other 3 vertices. I have to label corresponding vertices. So what does that mean? Well, say I have triangle ABC. There's triangle ABC. Well, by the side-side-side postulate, these triangles are clearly congruent to each other. But how exactly do I label it? What triangle is congruent to ABC? Well, you can't just label them in alphabetical order. This is not true. This is a wrong answer. And the reason is, what I have to label when I'm labeling triangle congruence is what the corresponding vertices are. So what that means is, if I look at my triangle, I'm looking for a vertex which corresponds to vertex A. Well, notice that A connects the side with 1 hash mark and the side with 2 hash marks. Well, let me find the vertex which corresponds to the 1 hash mark and the 2 hash mark. Well, the one that would correspond to that would be G. So the first vertex I'm going to label in my second triangle is the one which corresponds to A, which in this particular case is vertex G. So that's the first one I'm labeling because that's the one that is acting like vertex A in the first triangle. Now, if I want to figure out what the second one I'm looking for is, I'm looking for the vertex that corresponds to B, which connects the side with 1 hash mark and the one with 3 hash marks. So I see 1 hash mark, I see 3 hash marks, and that vertex will be E. So the second vertex I'm going to label in my triangle is going to be vertex E. And then the last one would actually be, by process of elimination, have to be vertex F. But just to double check, let's see why. If I look at vertex C, it's the side that connects the double hash and the 3 hash. So when I see my double hash and 3 hash mark, that's vertex F. So that's why vertex C corresponds to vertex F. Okay, so that's how you can determine how to label your congruence. So let's get this incorrect one out of the way. And that's how I would label my congruent triangles, corresponding parts with corresponding parts. So with that in mind, let's remember our three postulates that we just talked about and how to label congruence, and let's take a look at some examples to see whether or not there are any congruent triangles present here. So for the first one, do you see any congruent triangles? If you notice, I have an angle-angle side situation, which wasn't one of my three postulates. However, if you remember the vertical angle theorem, I know that this angle will be congruent to its vertical angle, and I now have an angle, side, angle, angle, side, angle situation. So by the angle, side, angle postulate, I can say that triangle ABE is congruent to triangle CBD. And notice that I did label my corresponding parts with corresponding parts. In the second one, it doesn't seem like I have an angle side angle or an angle angle side, and I only have 2 out of 3 sides for my side 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 postulate. However, if you note that side MO is present in part of both triangles, I can label that side as reflexive, and reflexive usually gets noted with this X for reflexive. I actually have 3 congruent sides. MN is congruent to OP, NO is congruent to PM, and MO is congruent to itself. So that is actually 3 sides. So by the side, side, side postulate, these 2 triangles will be congruent to each other. And again, that is the side, side, side postulate. So I'm going to write that down. Side, side, side postulate. And finally, for my third example, if you notice I have an angle side, I have an angle side, and then if you make that observation of my vertical angles are congruent again. So I have an angle side angle in my first triangle, but that's not the case I have in my second triangle. I have an angle angle side situation. So these triangles don't actually match up. I need, in order to use the angle side angle postulate, 2 triangles which match that pattern. Unfortunately, my second triangle doesn't match that pattern, so I'm stuck with no congruence. Okay, so those were 3 examples we've done together. I want you to look at the rest of your page of your handout, 4, 5, and the rest of the ones that follow. And I want you to try each of those examples, see if there are any congruent triangles present, identify which postulate you're using to conclude they're congruent, and appropriately label the congruence of those triangles. We'll go over those examples in class tomorrow.